asked in the exam. All right. Yes, it's challenging but fun. I can agree with you, Bandit. Okay, so there are 8 questions, type of speed question that I'm going to share with you. But today, probably we will have time to share only the first 5 strategy. Now, there are 8 types of speed question. The first one is journey by parts, and then average speed, same direction, start at the same time. Strategy 4, same direction, start at different time, closing the gap. Strategy 5, same direction, start at different time, opening the gap. Strategy 6, moving towards each other from opposite direction, start at the same time. Strategy 7, moving towards each other from opposite direction, start at different time. Strategy 8, moving away from each other from the same point. Okay, so there are many, these are the 8 common type of speed question. I think if you're able to understand and master these 8 type of speed question, I think you have a very good chance of scoring or acing your speed question in the PSLE. Okay, but they're not easy. I'm going to warn you that today's session is not going to be easy. It's going to be quite challenging. So I need you to listen very, very carefully. And the questions that I use in this today's session are also the challenging kind of questions. Okay, so I need you to listen very carefully, and I will try my best to slow down if you don't understand and to explain as much as I can. Okay, ready? Are we ready for the first question? The first type of speed question. Okay. Now, the first type of the speed question is what we call journey by parts. This is one of the easier speed question. Okay. Now, remember, for every speed question, you must draw the distance speed timeline. Now, percentage ratio question, you have model drawing, you have unitary method. But for speed, you seldom use model or you don't use units, but you have to draw the distance speed timeline. Now, many students, while you are practicing in school or in your daily practice in speed, you do not practice how to draw the distance speed timeline, right? You say, oh yeah, teacher, no need to draw, very easy, I can understand. Yes, the basics you can solve without drawing the distance speed timeline. But the exam question that you're going to see, okay, will be much more complex, right? Without drawing the timeline, the distance, and the speed timeline, you'll not be able to solve. Okay, so I'll show you what I mean by this. Now let's take a look at the first question. Okay, now let's read together. A motorist traveled 2/5 of his journey at 80 kilometers per hour, after which he decreased his speed to 60 kilometers per hour and completed the rest of his journey in 3.5 hours. Now you notice that there are 2 parts to the journey. The first part, the motorist traveled 2.5 or 2/5 of his journey at 80 kilometers per hour, and the second part is at 60 kilometers per hour, and they tell you that he completed the second part at 3.5 hours. So the part A, they ask you what was the total distance he traveled, and part B, given that the motorist reached his destination at 1:30 p.m., at what time did he start the journey? Okay, now let's take a look at the question. Now we need to analyze the question. Let's start by drawing the distance speed timeline. Okay, now the motorist traveled 2/5 of his journey. So the first part of the journey, this is the first part. Now 2 units, how do I get 2 units? Because 2 out of 5, right? The entire distance is 5 units. So the first part is 2 units. Okay, the second part is 3 units. Okay, so the first part, he traveled at 80 kilometers per hour. Okay, after which he decreased his speed from 80 kilometers per hour to 60 kilometers per hour, and he completed the rest of his journey in 3.5 hours. Okay, so now what we are doing, we have not calculated anything. What we do is that we draw the distance speed timeline and put in all the information given to you in the question in the timeline. All right, write down all the information given to you in the timeline. Now, Remember the formula. This is the formula that you need to know, right? DST formula, right? DST. Now, D stands for distance, S stands for speed, and T stands for time. Now, if you want to find distance, the formula is speed multiplied by time. If you want to find speed, distance divided by time. If you want to find time, distance divided by speed. So all of you should know this by now, the basic concept, the basic formula. Now, if you take a look at this diagram, at this timeline, they have given to you the speed and the time in the second part of the journey. Now, you don't have to do anything else. The very first thing that you do is to find what is missing here, the missing variable. They give you speed, they give you time. Straight away, you can find the distance, right? They give you this variable, the S, and they give you the T. Straight away, you don't even have to think anything else. Straight away, you go and find the distance. Because why? This will be the additional information that is going to help you solve the remaining part of the problem. Okay? Okay, so what we're going to do, we're going to find the distance, right? The formula for this is speed times time. So since the speed in the second part of the journey is 60 kilometers per hour, the time is 3.5. 60 kilometers per hour times 3.5, you get 210 kilometers. So the distance in the second part of the journey is 210 kilometers. Okay? And you can see that 210 is 3 units. Okay? 210 is 3 units. And they ask you what's the total distance you travel. So very simple. We are going to use ratio. So 3 units is 210 kilometers. 1 unit will be 210 divided by 3. You get 70 kilometers. And 5 units. Why 5 units? Because they ask you what is the total distance traveled. The total distance, 2 units plus 3 units, you get 5 units. 70 multiplied by 5, you get 350 kilometers. Okay, so that is the answer for part A. Okay, so part A is relatively simple. All right, quite straightforward. You need to use the concept of ratio or units. Okay, now let's take a look at the second part. Part B, they tell you that given the motorist reached his destination at 1:30 p.m., at what time did he start his journey? Okay, so they tell you he reached at 1:30, so you need to work backwards. You need to find out at what time did he start the journey. Meaning that you must know or you must calculate how long did he travel. What is the total duration of his travel? Right? How long? 1 hour, 2 hours, 3 hours. Then you can work backwards to find the time that he start his journey. Okay, so that's what we're going to find. We are going to find how long he took to travel the journey. Okay. All right. So in the first part of the journey, we know that he took 2 units. Right? Since we know 1 unit is 70, 2 units will be 70 kilometers times 2, 140 kilometers. Okay, so this part is 140 kilometers. All right. So in the first 140 kilometers, the motorists travel at 80 kilometers per hour. Remember, the speed is different. So you need to calculate the time taken separately for the first part of the journey. Okay? So since the first part of the journey, he traveled at 80 kilometers per hour for a distance of 140 kilometers. Okay? So the time taken, remember the formula, time is distance divided by speed. So distance is 140 kilometers, the speed is 80, you get 1.75 hours. Now take note, 1.75 hours is not 1 hour 75 minutes. They are different. So many students have difficulty converting. So if you have difficulty converting from minutes to hours, okay, you need to sort that out. These things should be familiar to you when you at primary 4 or primary 5. Okay? Now, so the total time taken for the journey, the first part is 1.75 hours, and then the second part is 3.5 hours, which was already given in the question. So the total time taken is 1.75 plus 3.5, you get 5.25 hours. Okay, 5.25. I convert 2 hours and minute, I get 5 hours 15 minutes. Some student 5.25 hours, you put 5 hours 25 minutes. Wrong, right? Because 1 hour is 60 minutes. Okay, then question. So then teacher, how to convert 0.25 hours into minutes? Very simple, right? Because 0.25 is, you need to convert 25 over 60, right? 25 over 60. Okay, so that you can convert in hours to times. Okay, and then you get 5 hours and 15 minutes. So what do you do next? You work backwards, right? You work backwards. 1 hour 30 minutes. Okay, you work backwards. 1 hour 1:30 p.m. You minus off 5 hours 15 minutes, and you find out that the motorist start the journey at 8:15 a.m. Okay, 8:15 a.m. Now, how do you do this? You need to use the timeline method. Okay, the timeline method. So since 5 hours and 15 minutes, you need to jump 5 hours backwards. Okay, 1:30, you jump 1 hour, you jump 1 hour. Okay, so you work backwards. 12:30, 12:30, 11:30, 10:30, 9:30, 8:30. So 5 hours, but not enough, right? You still got 15 minutes. Okay, so 8:30 minus less 15 minutes, you get 8:15 a.m. So you need to do the timeline method, okay, when you work backwards. Okay, class? All right. So far, so good? Easy, yeah? So this is just the starter. Okay, the first type of question is journey by parts. Okay, let's take a look at the next type of speed question, what we call the average speed question. Okay, now let's read together. At 11:50, Kiran started cycling at 25 kilometers per hour from her home to a park 10 kilometers away. She was at the park for 1 hour and 50 minutes. What time did she leave the park? And part B, after leaving the park, Kiran cycled back along the same route and took 40 minutes to reach home. What was her average speed in kilometers per hour for the journey home? Okay? Tasina say very easy. You sure or not, Tasina? Okay? Those of you who can work out and get the answer, just write down in the chat function here. Okay? All right. So again, we are going to do step by step. We're going to tackle part A first. Again, always start by drawing the distance speed timeline. Okay? Now, let's take a look at the timeline. So at 11:50, right, Kiran started cycling. Right, speed 1. Speed is 25 kilometers per hour. Distance is 10 kilometers. So remember, when they give you distance, they give you speed. Straight away, don't waste time, you find the time. What's the formula for time? Distance divided by speed. Right? Distance divided by speed. Now, this is the first part of the journey, right? When she cycled towards the park. So that's why I put T1. T1 means the first part of the journey. S1 is the first part of her journey, when she cycled from her home to the park. All right, so speed is given, distance is given, straight away, don't waste time, straight away find the time taken. Time is distance divided by speed, 10 divided by 25, you get 0.4 hours, convert to minutes, okay, multiply by 60, you get 24 minutes. Okay, you get 24 minutes. So she took 24 minutes to cycle from her home to her park. Okay, so 11:50 plus 24 minutes, right? 11:50 plus 24 minutes, you get 12:14. Okay, 12:14, and then remember, she was at the park for 1 hour and 50 minutes. So you need to add on 1 hour 50 minutes, and you get 14:04. 14:04. You take note, this is what we call a 24-hour clock. A clock got the 24-hour clock or the 12-hour clock. The 12-hour clock, you need to state AM or PM. But 24 hours clock, you don't need to state AM, PM, because here is actually 14:04 is 2:04 PM. right? Because the time given here is in 24-hour format. Your answer, you must leave in the 24 hours format as well. Okay? All right, very good. So first part is relatively easy. Now, second part is even easier actually. Okay, so now the second part is that after leaving the park, Kiran cycled back along the same routes. Now remember, the same route means that if she cycled for 10 kilometers from her home to the park, that means going back is also will be 10 kilometers. So the distance is the same. Remember that. Huh? If they go to one point and then back to the same original point, the distance is the same. Okay, so what's the average speed? Speed is total is distance divided by time. So the distance is 10 kilometers and the time is 40 minutes. Now this is the problematic part. Now many students, what they do is that 10 divided by 40. Okay, 10 divided by 40. What's the problem if you 10 divided by 40? Anyone? Because you say that speed is distance divided by time. Distance is 10 and the time is 40. What's the problem? The problem is the speed is in kilometers per hour, but the time here is in minutes, right? So the units are not the same, right? You cannot add or do any calculation if the units are different. $1 and 1 cent, are they the same? Very different, right? So likewise here, if the speed, they require you to write the speed in kilometers per hour, you must make sure that the time given here is also in hours. So you need to convert. Now, how do you convert 40 minutes to hours? How do you convert? Very simple. 40 minutes is 40 over 60 hours. Okay? 40 over 60. Okay? So speed is distance divided by time. Distance, is 10 kilometers. And the time is 40 over 60. Yeah? 40 over 60, you just punch in your calculator and you get 15 kilometers per hour. Okay? So far so good, class? Very good? Easy? Very easy, yeah? Okay, well done. Anybody have problems? Easy, yeah? Okay, very good. We shall see, yeah? Now let's move on to the next type of question. Okay, same direction, start at the same time. What is this? Now we're going to start the more complex type of question. Huh? Okay, same direction, start at the same time. Now I'm going to show you what we mean by this. Huh? Same direction, start at the same time means what? Like you are starting a race. Okay, race going towards the same direction and start at the same time. Now this is quite a simple question on speed. Okay, where they tell you that there are two person, okay, which is moving at the same direction and starting at the same time. Okay, now this is an illustration for you. Huh? Now let's take a look at the question. Okay, let's take a look at the question. Huh? Okay, Hairi, you have missed 2 questions. No problem. We have recorded the first 2 questions. Later on, you can always review. That's the best part about the online lesson. Okay, let's read together. Sharon and Singi started cycling along at the same time along a 4.5 kilometers track. Okay, both did not change their speed from the start to finish. Sharon cycled at 375 meters per minute. When she reached the end of the track, Singi was 600 meters behind her. What was Singi cycling speed in meters per minute? Okay, let's analyze the question first. First, they tell you that they start at the same time, right? They start at the same time and along the same routes, right? The track is 4.5 kilometers. The speed is the same, meaning constant speed throughout the race. Okay, and they tell you that when Sharon reached the end of the track, that means when she completed the race, Singi was behind. So automatically we know that the speed of Singi will be lesser than Sharon. Correct, right? So your answer must be less than 375 meters per minute. So if you calculate and then you get your answer more than 375, you know something is not right. So you better check and change your answer. Okay, I repeat. Here, they tell you that Singy was 600 meters behind Sharon when Sharon reached the end. And Singy, they ask you what was Singy's cycling speed. By logical thinking, we know that Singy's cycling speed must be less than Sharon because Singy is lagging behind, right? Singy is behind Sharon. Okay? Now let's start by drawing the distance speed time as usual. Okay? So Sharon, when she reached at the end, Singy, X stand for Singy, yeah? Singy is 600 meters behind. And we know that the track is 4.5 kilometers. Now let's convert everything to meters, right? Because this is in kilometers, this is in meters. Okay, calculation will be very difficult. So to facilitate calculation, we need to convert 4.5 kilometers to meters, right? Very simple. We just multiply by 1,000. Okay, right? And now the other thing that we should take note of is that the time is constant for both cyclists when Sharon reached the end. Meaning that, you see, when Sharon reached the end, Singy is 600 meters behind her, right? So if Singy took, say, 1 hour to complete the race, that means at this point, Singy has also cycled for 1 hour. Okay, this is what I meant by the time is constant for both cyclists when Sharon reached the end. So this is something that you need to take note of. Okay, now let's take a look how to continue this question. Now, since they ask you, right, what was Singy's cycling speed? Now, first, this is the time taken for Sharon. The time taken, time is distance divided by speed. Okay, since the distance which Sharon cycled was 4.5 kilometers, we convert to meters. So 4,500 divided by the speed for Sharon, right? 4,500 divided by 375, you get 12 minutes. So time taken for Sharon to complete the race is 12 minutes. So Sharon, when she reached the end, the finishing point, she took 12 minutes. It is at the 12 minute, right? 12 minute. Now here, Singy, at this point, she has also cycled for 12 minutes, correct or not? That means Singy is also 12 minutes here. So this is something that you should take note of, right? So that means from start to this point, okay, Singy has cycled for 12 minutes. And what was the distance traveled by Singy? 3,900. Now, how do I get 3,900? 4,500 minus 600 meters. So that's why we need to draw the distance timeline so that you can see very clearly, right? And illustrate very clearly the problem. So distance X, distance from here to here, 4,500 divided by 600, you get 3,900. So the speed is distance divided by time, right? So the distance is 3,900. The time taken is 12. Okay, so 3,900 divided by 12, you get 325 meters per minute. Answer. Okay, guys? All right, Khairi, understand now? Shafiq? Okay, anybody still don't understand? You got it, Khairi? Okay. Shafiq don't understand? Shafiq, which part you don't understand? Imran? Okay, very good. I'm happy that you understand. Okay, very good. Well done. Okay, let's move on to the next type of question. Next question. Okay. Now, number 4. Next strategy or next type of speed question that you see in the exam is same direction, start at different time, but closing the gap. What do I mean by this? Right? Remember, just now, strategy number 3 was same direction, start at the same time, right? But here, start at different time. Now, later on, strategy number 5, we are going to do slightly different. Same direction, start different time, and opening the gap. But here, same direction, start at different time, but closing the gap. Okay. Now, let's take a look what I mean by this. Okay? Meaning that you can see these two cyclists, right? These two cyclists, they are moving towards the same direction, right? They're moving towards the same direction. They start at different timing, right? One of them could start earlier, right? One of them start earlier than the other. Okay, and then this person here, right? This cyclist, the second cyclist, will start later, but it will close the gap, and eventually overtake the first cyclist. Either overtake or they will catch up with the first cyclist. So that is what I mean by closing the gap. Okay, so you can imagine you let your friend cycle first, and then you tell your friend, okay, go, you cycle first. Later, I will catch up. The only way to catch up is for the second cyclist to cycle faster than the first cyclist. Right? When the second cyclist cycle faster, then they can catch up. If not, if the second cyclist cycles slower, then the gap will widen. That strategy we are going to do on after this. Okay, class, understand? You can see this? Okay, so far so good? Ain, you understand? Okay, well done. Okay, let's take a look at the question. Okay, so when we are answering this question, a few things that you must take note. The faster object, which starts later, usually overtakes the slow object before they reach their final destination. Right? Remember, the second object is faster, so they will catch up and it could overtake, depending on the question. Now, since they start at a different time, there will be a distance between them at the start. At the start, there's already a gap. Okay, at the start, there's already a gap. So the second object or the second person will move faster, the speed will be faster to catch up. Okay, let's take a look at this sample here, this example. At 10:30 a.m., a cyclist started traveling on a road at an average speed of 30 kilometers per hour. At 2:30 p.m., a motorist, this is the second person, at first is cyclist, then the motorist. And we know the motorists move faster, right? Cyclists very slow, motorists use engine faster. Okay, the motorist started from the same place, traveling on the same road. So what happened? The motorist took 4 hours to catch up with the cyclist. Find the average speed of the motorist. Now, by logical thinking, do you think that your answer will be more or less than 30? Will your answer be more or less than 30 kilometers per hour? By logical thinking. Obviously, it will be more. Why more? Why more? Because the motorists need to travel at a higher speed to catch up with the cyclist. Correct or not? So since the cyclists travel at 30 kilometers per hour, all right, so the motorist will take a faster speed to catch up. Your final answer must be more than 30 kilometers per hour. Okay, again, let's start the question by drawing the distance, speed, timeline and inputting all the information as usual. Okay, let's take a look at how it's done. So you can see here at 10:30 a.m., the cyclists at 30 kilometers per hour start moving, start cycling. Okay. Then cycle. At 2:30 p.m., when the cyclist is somewhere in the middle, right, somewhere in between the journey, the motorist start to move, start his journey at 2:30 p.m. How many hours later? 10, 11, 12, 1, 2. That means 4 hours later, then the motorist start traveling. Okay, so the motorist start traveling 4 hours after the cyclist has started the journey. So the next part, they tell you that if the motorist took 4 hours to catch up with the cyclist, another 4 hours, that means when the cyclist is at 2:30 p.m., right, at 6:30 p.m., then the cyclist and the motorist will be together. This is where the motorist and the cyclist, they are able to be side by side. The motorists are able to catch up with the cyclist at exactly 6:30 p.m. And 6:30 p.m. is how many hours after? 2:30, 3:30, 4:30, 5:30, 6:30. That means after another 4 hours, right? Then the cyclists and the motorists, they're able to be together. That means motorists are able to catch up after 4 hours, right? That means from 2:30 to 6:30, right? The motorists took 4 hours to catch up. Okay, the motorist traveled 4 hours to catch up, but the cyclist in total, can you tell? In total, the cyclist has cycled how many hours? Can you write down your answer? Motorist took 4 hours, right, to catch up. The cyclist has traveled, Zufairi, 8 hours. Ashraf, well done, very good. How you get 8 hours? From 11:30 all the way until 6:30, right? 4 hours in the beginning. Okay, and then another 4 hours later. All right, so 4 hours plus another 4 hours, you get 8 hours. Very good, well done, huh? Okay, I know some of you are a bit lost, but not to worry, huh? Later you can repeat this. Huh? I know some of you are still, some of you even just started learning speed in school, right? Any of you just started learning or just completed speed topic on speed in school? No, finished, just before the exams, before the mid-year exams, right? Okay. Let's continue. Let's continue. So when the motorist catches up, the cyclist had traveled 8 hours, right? Most of you got the correct answer. Okay, the cyclist had traveled 8 hours. So then we find what is the distance traveled by the cyclist. Since the cyclist speed is 30 kilometers per hour, okay, and the time taken is 8 hours, so distance is speed times time. Speed is 30, time is 8 hours, so 8 multiplied by 30, you get 240 kilometers. So you know that the cyclist had traveled a distance of 240 kilometers. Okay, so this is the distance traveled by the cyclist as well as the motorist, right? And what's the speed of the motorist? So since the distance is the same, right? Remember from here to here, the distance is the same, right? The cyclist took 8 hours, the motorist took 4 hours, but both of them has covered the same distance, right? Remember the motorist traveled faster. The speed of motorist is faster. Okay, so since the distance is 240 kilometers and the time taken for the motorist is 4 hours, 240 kilometers divided by 4 hours, you get 60 kilometers per hour. What happened? Okay, suddenly become big. Okay, suddenly, okay, I don't know what happened. Okay, so the answer is 60 kilometers per hour. All right, all of you got that? All okay? Okay, let's move on to the final strategy. Are we ready? So far, so good? Okay, let's move on to the final strategy. This one a little bit more challenging. Okay, it gets tougher and tougher. Now, what happens is that they travel the same direction, start at different time, but the gap is opening. What do I mean by opening the gap? So this is what I meant. Now, the first cyclist here traveled first, right? The second cyclist traveled later. However, the second cyclist is slower than the first cyclist. So what happened here? The gap become bigger and bigger, right? From here to here, at first from here to here, okay, and then the gap becomes bigger, the wider, right? From first and the second cyclist, at first this is the gap, and then after that, the gaps become wider from here to here, right? So this is what I mean by opening the gap. Okay, opening the gap. Now let's take a look at the question, then you can understand better. Now this question tests students on scenario whereby two objects start from the same location at different speed and one will be further away from another. Okay, now let's take a look at this question. John started cycling from point A to point B at 7 a.m. at an average speed of 12 kilometers per hour. David started cycling from point A to point B 3 hours later. John's speed is twice of David's. At what time were the two cyclists 48 kilometers apart? Okay? Can all of you try? Can all of you work out on your own first? Okay, let me give you all 3 minutes to work out. Okay, you have a piece of paper with you, your foolscap paper, take your calculator and your pencil. I want you to work out this question. All right, so I'm going to give you about 3 to 4 minutes. And once you get the answer, you just write the answer down at the chat function. Okay? In the meantime, I'm going to the toilet for a while. Okay? Okay, you're going to answer? 3 p.m., 12 p.m., 1 p.m. Eh, only a few of you. The rest of you, what happened? Twelve p.m. No, 4 hours. 12 p.m., 1 p.m., 15 p.m. Zufairi, what is 15 p.m.? 3 p.m., 12 p.m., 3 p.m., 2 p.m., 11. It's hard. I'm stuck. Okay. Let's do together. Huh? Okay, I can see different answers. Huh? Okay, no problem. Okay, let's do together. Okay, 1 p.m. All right, let's see. Some of you got the correct answer. Okay, but let's see how to do this. Most importantly, we learn how to solve this type of question. Okay, now let's read the question again. John started cycling from point A to point B at 7 a.m. at an average speed of 12 kilometers per hour. David started cycling from A to B 3 hours later. And John's speed is twice, meaning that John, who cycled first, right, the gap will widen with David. Correct or not? Why? Because his speed, John's speed, is twice that of David. So it means that David will never be able to catch up. Right? That means the gap will wider and wider and wider and wider. Okay, as throughout the journey. So the question is at what time were the two cyclists 48 kilometers apart? Okay, let's take a look. Let's draw the distance speed timeline to understand the problem better. So at 7 a.m., John cycled at a speed of 12 kilometers per hour. Right? John cycle. Then 3 hours later, David started cycling. 3 hours means 10 a.m. Right? 7, 8, 9, 10. 10 a.m., David cycled at 6 kilometers per hour. Right? Because David speed is half. Right? So John is twice. David is half, 6 kilometers per hour. And then after cycling, right, John is in front, David will be behind, right? So John will always be in front and David will never be able to catch up. Correct, right? Because John has already cycled first and the speed of John is twice that of David. So that means David will never be able to catch up. Okay? So basically the question asks you, at what time were the two cyclists 48 kilometers apart? Okay, at what time? So at what time here will the distance be 48 kilometers? Right? So this is the distance speed timeline. Okay, and we are going to solve this. So what we do first? Now, since we know the speed of John, which is 12 kilometers per hour, and we know the time taken, right, is 3 hours. Okay, after 3 hours, so 12 times 3 hours, you get 36 kilometers. So that means when David started his journey at 10 a.m., John has already been ahead by 36 kilometers. Correct? Not? In 3 hours, right, John had cycled a total of 36 kilometers. That means the initial gap is 36 kilometers. All of you got that? Okay, so the initial gap will be 36 kilometers. Why? Because John, in 3 hours, right, then David started the journey. But when David started the journey, right, John has already cycled a distance of 36 kilometers per hour. How do we know? 36 kilometers. How do you know? Because his speed is 12 kilometers per hour and the time is 3 hours. So 12 times 3, you get 36 kilometers. So that means before David started his journey, or as David was about to start his journey, John already have a head start of 36 kilometers. Okay, and what happened? When David starts the journey, the gap becomes wider and wider. Why become wider and wider? Very simple, because John's speed is twice that of David. Okay, now let's take a look what happened next. Okay, next step is we are going to find the increase in the gap. So we want to know at what time were the two cyclists 48 kilometers apart. Since at the start is 36 kilometers, so the difference is 48 minus 36, 12 kilometers. Okay, so there is an increase in the gap by 12 kilometers. Right? Increase in the gap by 12 kilometers. And since the speed for David is 6 kilometers per hour, okay, John is twice okay, the speed is twice. That means for every 1 hour, John is ahead by 6 kilometers. Why? Because the speed for John is 12 kilometers per hour. David is only 6 kilometers per hour. For every 1 hour, John will be ahead by 6 kilometers. Okay? So to be ahead by 12 kilometers, how many hours does it take? It will take 12 divided by 6. It will take 2 hours. That means 2 hours for the gap to increase by 12 kilometers so that they are apart by 48 kilometers. Right? So how do we get that? 2 hours, 12 divided by 6, you get 2 hours. So when they start at 10 a.m., so plus 2 hours, you get 12 p.m. Right? So the answer is 12 p.m. Who got the correct answer? Well done. Those who get the correct answer. All of you do it by yourself. Those of you who get the correct answer, you do by yourself. Wandit, well done. Daniel, Hani, Ashraf. Okay, wonderful. Imran, you just understand? Well done. If you don't understand, perfectly fine. I don't expect you to understand 100% now. Especially some of you, you are not that strong in speed. No problem. That's why I'm recording this and I'm going to upload and I share with your parents later on the link. Okay, later on you can always review this lesson. Okay, and until you understand. That's the best part of the online learning. You can review, you can pause anytime. Okay, this is the first part. So we now is 8:50 already. I have 3 more types of speed question which I'm going to share in my next webinar. Okay. Now class, Daniel say laggy. Okay, Daniel, if you laggy, there's nothing I can do because my internet here is fine. All right. Some other students, no problem. So you have to check your internet connection. All right. Okay, so no problem because I'm recording this. So I think the recorded part will not be laggy. Yeah. Okay. All right, class. Any question? Any question you have at the moment? No question? Okay, no question. I think I shall not keep you. Some of you have exams tomorrow. Okay, I wish you all the very best. Those of you having an oral exam, please relax yourself. Wake up early, sleep early tonight. Have a good breakfast, but not too much. Right? Have a healthy breakfast, and then be calm, be confident. Whatever that you have learned, your notes and so on, just revise them and be confident in responding to your examiners. Okay. All right. Okay. Thank you very much, everyone. All the very best. Bye-bye. See you in the lessons.